In this video, I'm going to talk to you about how to factor complex factors. And so our learning target is I can factor polynomials to include complex factors. All right, so sometimes you look at a problem and you're like, well, that would meet all the requirements of difference of squares, except it's not a negative 36, right? So I want to kind of remind you about complex numbers in general, okay? So kind of off here to the side, think about if I had a 6i and a negative 6i. Well, that would be negative 36i squared, right? So think about difference of squares. You know, you have a positive 6 and a negative 6, right? Which would give you negative 36. The difference, though, is when this I is tacked on, remember, I squared gets replaced with a negative 1, and that ultimately makes this a positive 36 instead of a negative 36. All right, so when we look at this example down here, then we think, okay, well, yeah, how can I get, the 36? Well, 36 could be gotten by saying 6i times negative 6i. All right, so n squared is like n times n, but 36 would be like 6i times negative 6i. Now, the reason why that will work is because if we were to redistribute our answer, well, let me go ahead and write it down first. So we would have an n plus a 6i and an n minus a 6i. All right, if I were to redistribute this, I'd get my n squared, but then here I'd have a negative 6in or a negative 6ni, however you want to write it, and then a positive 6in. All right, well, that negative and that positive would cancel out in the middle, right? Just like it does with difference of squares. And then the positive times the negative here gives me the negative 36i squared, which ultimately is the positive 36. So anytime that you have something that looks like difference of squares, like it would qualify other than the fact that it's a positive instead of a negative, then you can use complex factors instead of your real number factors. All right, so we can break that down like that. All right, so if I had another example, I don't really want to waste space on here, but if I had another example and I had x squared plus, I don't know, 49, like that. Well, then x squared is x times x, and 49 is 7 times 7, right? But if we had 7 times 7, then when we were multiplying that out, 7 plus 7 is 14. We need this middle term to go away. So we need one of these to be a positive and one of these to be a negative. The problem is 7 times negative 7 is not 49. But if I did 7i times negative 7i, then that's negative 49i squared, which becomes a positive 49, okay? So that's pretty much how we're breaking that down. All right, now once you have the complex factors, so if we go back to this problem, then you can set each of those equal to 0 and then solve for your variable. All right, so n plus 6i equals 0, n minus 6i equals 0. All right, so I would subtract 6i from both sides and get a negative 6i. And on this side, I'd add the 6i to both sides to get the positive 6i. So ultimately, our solutions then would be plus or minus 6i. All right. So another example, all right, 4a squared plus 25, think about how things are going to break down. All right, so everything about this is perfect square, right? 4a squared, 25, it's all perfect squares. All right, but it's missing that subtraction here, right? So the only thing we're going to have to do is tack on that I, because then the I squared would ultimately change that sign. So this would break down as your 2a times your 2a, and this would break down as not just 5 and 5, but 5i and negative 5i. Now, I don't need to see you necessarily break this down. I'm just trying to show you so that you can see it, for the notes. All right, so when we break this down, we're going to have a 2a plus 5i and a 2a minus 5i. All right, so those are our factors. All right, so remember, factors are what you multiply to get something else. But if I went a step further and I was solving it, then I would set each of these factors equal to 0. All right, so for the first one, I'd subtract the 5i, and then I'd divide by 2. So A would be a negative 5/2 I. That's one solution. And then the other side, I'm adding the 5i. So you may already start to kind of see that it's just going to be plus or minus negative, or plus or minus 5/2 I, right? But I'm showing you the process. All right, so then we're going to divide by 2. And A is a positive 5/2 I. All right, so again, we could say plus or minus 5/2 I. Okay. All right, so the third example here, we have a GCF. So remember, you always factor out a GCF if you can. So we keep the 5, that's the GCF, and we're left with q squared plus 9. Again, this is kind of like difference of squares, except it's positive. So that's where we're going to have complex factors instead. So we're going to have the 5, and we're going to have a q plus 3i and a q minus 3i. All right, so this is factored form. Now, if I want to solve it, then I would set each factor equal to 0. All right, and then solve for the variable. All right, well, 5 equals 0 is not even true. You can't even solve that. That's not even a true statement. All right, so you can't do that. All right, so for the second one, we're going to subtract the 3i. So we get a negative 3i. And for the third one, we add the 3i to get positive 3i. And again, these could be written as q equals plus or minus 3i. All right, so you can separate it out, or you can kind of put it together with the plus or minus with it. All right, so you're working on 1 through 3 at the bottom of that page. And so I'm going to show you the answers, but I'd like you to press pause and try those first, because obviously I don't, if you see the answers right away, then it's not going to be as beneficial, okay? So pause the video and then try those, and then come back and then check your answers. And here they are.